أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all to the channel today. In today's problem, we have problem 5 according to the lecture notes, and you can see that it is a bit different from what is actually in the lecture note because I made some additions which I feel will help you greatly in solving problems on vectors. Now let us begin by reading the problem. Problem 5 says if vector A has negative 12 units along the x-axis, 7 units along the y-axis, plus 13 units along the z-axis, and you have a second vector B which has no component along the x-axis, and that is why you do not see I cap here because it has no effective value along the x-axis, but its effective value along the y-axis is negative 3, and then its effective value along the z-axis is plus 7. So you have these two vectors. Here are what we are asked to find. The first thing said we should find the vector sum of A and B. Second, it says we should subtract vector B from vector A. Thirdly, we should subtract vector A from vector B. And then fourthly, we should subtract 3 times vector B from twice vector A. Then the E part of the problem says we should find the magnitude of vector A, vector B, the magnitude of the vector sum of A and B, magnitude of vector B subtracted from vector A, and magnitude of twice vector A minus 3 times vector B. Finally, this F, very interesting, we should find the unit vector in the direction of A and the unit vector in the direction of B. Now, without any delay, let us give it a start. Let's start solving the problem. Okay, we are starting with I'm going to write solution here. Okay, solution. Then I will write A. I am solving the A part of the problem. The A part of the problem says that we should find vector A added to vector B. So what we are going to do now is that I will write a bracket. This bracket I'm going to write vector A inside, then I have a plus sign here, and then I need a second bracket for my vector B. Vector A according to the problem says negative 12 I cap plus 7 J cap, and then plus 13 K cap. Then vector B is negative 3 J cap plus 7 K cap. Now, since I don't have any negative sign here or a number, of course there is one but it's ignored, my terms in the bracket will not be affected, so I will just remove the bracket and I have negative 12 I cap plus 7 J cap plus 13 K cap. Again, since this is a plus sign, my terms in the bracket will not be affected. Again, I will just open the bracket. This minus 3j cap will come out as minus 3j cap, nothing has changed. This one will also come out as 7k cap, nothing has changed. So this is equal to, the next thing is I'm going to group the like terms. Since I have only one term in I cap, it will remain unchanged, minus 12 I cap, but then I have 7 J cap, and this is minus 3 J cap. Then I have plus 13 K cap, then plus 7 K cap. Now, after grouping the like terms, make sure you add the terms 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you did not leave any term. This is equal to, so minus 12 I cap. Now I will do the subtraction here. 7 minus 3 will give me plus 4. I have J cap. then 13 plus 7 will be 20, so I have plus 20 k cap. This is my vector sum of A and B. Then I will move on to the B. B says we should get A minus B, vector B subtracted from vector A. So again, I need two brackets. Then I put a negative sign here. The first bracket for vector A and the second one for vector B. Okay, for vector A, I will have to write negative 12. Oh my God, sorry. I will have to write negative 12 I cap plus 7 j cap and then plus 13 k cap. And then here I will have to write negative 3 j cap plus 7 k cap. As in A above, since I don't have any negative sign here, so all the terms in the bracket will remain unchanged, and I'm going to open the bracket. This one will come out as negative 12 I cap and then plus 7 k cap plus 13 j cap here, j cap, then plus 13 k cap. Now this is important because I have a negative sign here. It will change every negative in the bracket to positive and every positive to a negative. This means minus 3 j cap will become plus 3 j cap, and then plus 7 k cap will become minus 7 k cap. Now I will group the like terms. I have only one term in I cap, so I have minus 12 I cap, and then I have this is plus 7 j cap plus 3 j cap, so I have plus 7 j cap plus 3 j cap. And then finally the k cap, I have plus 13 k cap minus 7 k cap. This is equal to, remember we have only one term in I cap, so it will remain unchanged. Minus 12 I cap, then 7 plus 3 will give me 10, so I have plus 10 j cap, and then 13 minus 7. In case you will get confused, always use your calculator, open it, press 13 minus 7. 13 minus 7, you see that equality sign, you have 6. This 6 is positive, so you have plus 6 k cap. This is vector A minus vector B. Then we move on to C. C says we should get vector B minus vector A, and again I need two bracket minus. Okay, in the first one I write my vector B, which is negative 3 j cap. Remember it has no I cap according to what we are given, so 7 k cap. And then here I have negative 12 I cap for my A plus 7 j cap plus 13 k cap. Now this is equal to, again I have no negative sign here, so my terms in the bracket will not be changed. I will have minus 3 j cap plus 7 k cap. But this, because I have a negative sign here, it will affect everything here. The negative will be transformed to positive, and every positive term will be transformed into a negative term. So minus 12 I cap will come out as plus 12 I cap, plus 7 j cap will come out as minus 7 j cap, and then plus 13 k cap will come out as minus 13 k cap. This is equal to, again we will group the like terms, and customarily we will start with the I cap, the term in I cap. Look at it here, and it is positive here, so we have 12 I cap. Then terms in J cap, I have minus 3 J cap here, and then look at it here again, minus 7 J cap. And then terms in K cap, I have plus 7 K cap and then minus 13 K cap. Let me count the terms to make sure that yes, I am correct. 1 2 3 4 5. 1 2 3 4 5. So I did not leave any terms. This is equal to my 12 I cap. Then minus 3 minus 7 is minus 10. But to confirm that, always use your calculator. Minus 3 here, minus 10 here for the J. So look at it here. You press minus 3 minus 7 is equal to, you see, minus 10, minus 10. So you now write your minus 10 J cap. Then here 7 minus 13, so you bring your calculator and press that again. Plus 7, see, plus 7 minus 13, this will give you minus 6. So you have minus 6 k cap. This is your vector B minus vector A. Okay, then we quickly move on to the D part of the problem. And the D part of the problem says we should get twice vector A minus 3 times vector B. Okay, now how do we get this one? Again, I'm going to write 2 here, then I open a bracket. Then here I will write my vector A, then minus 3, I open bracket, and here I will write my vector B. Okay, this is equal to, now I have 2 inside my vector A, remember, is negative 12, negative oh, I'm sorry, I can write, I have to write it here. So I have negative 12 I cap, plus 7 J cap, and then plus 13 K cap, and then here negative 3 J cap plus 7 K cap. This is my A and this is my B. Now I can clear the bracket. Now clearing the bracket here, I want you to pay attention here because it's very important. But these two will be multiplied by what you have here, you record, you multiply by 7, you record, you multiply by this 13, and you record your result. So we are going to say, look at it here. You said, in case it will confuse you, press 2 here, then you open bracket and press minus 12, you close bracket, equality sign. You see, this means 2, let me bring it, you see, 2 into negative 12 minus 24. So here what you have here will come out as minus 24 I cap. Then you have 2 into 7. Do that yourself and see, 2 into plus 7 close bracket. You see, 2 into plus 7, you see, this is 14 and it's positive, so you have plus 14 J cap. Then you do it for the K cap, 2 into plus 13. Okay, 2 into plus 13, what do we have? 2 into plus 13, you close bracket. Okay, look at what you have. 2 into plus 13, 26, and it's positive, so you have plus 26 K cap. Now this minus 3 will affect everything inside, so minus 3 minus 3, so you press minus 3 here, and then you open bracket and say minus 3 for the minus 3 inside, you close bracket, and then press equality sign here, you get 9, and this 9 is positive, so what you have here is plus 9 J cap. And again you press minus 3 again, open bracket, then the next number here is plus 7, so plus 7, oh I'm sorry, minus 3, you open the bracket and say plus 7, you close the bracket. This is equal to, you see, negative 21, so you now press negative 21 K cap. Good. The next thing is we have to group our like terms, and we know that we have only one term in I cap, so this will remain unchanged, minus 24 I cap, and then plus this is 14 j cap. Where is another j cap? And plus 9 j cap, and then you then have plus 26 k cap minus 21 k cap. Okay, this is equal to minus 24 I cap. Now add plus 14 plus 9. The sign, please do not leave the sign. Okay, plus 14 plus 9. What do you have? Plus 14 plus 9 plus 23. So you have plus 23 j cap. Then here I have plus 26 minus 21. Look at it here. Plus 26 minus 21, you have 5 and it's positive, so you have plus 5 k cap. This is your result for D. Then we move on to E, where we'll find magnitude of our vectors. Alhamdulillah, for E says we should find the magnitude of vector A. Remember, your vector A is negative 12 I cap plus 7 j cap plus 13 k cap. Okay, so the magnitude of A, you can write it like this, or you simply remove the vector and the vector arrow here. Whether you write it like this or like this, you mean magnitude of A. And how do we get that magnitude? We say square root, okay, and then you take its component along the x-axis. This is negative 12. If it is negative, make sure you insert it in a bracket, and now you square it, plus you take its component along the y-axis, 7, you square it, you take its component along the z-axis, 13, and you square it. Okay, this is equal to, okay, square root of, okay, bring your calculator, okay, open bracket here, put the negative sign, and then 12 close bracket and square it. You see, now your answer is positive. Okay, 144, and it's positive, so I have 144. Then plus, bring the calculator again, press number 7, square this number 7, and then you have 49. So I have 49 plus, again I have 13. I bring my calculator, 13, and I press the square button, 13 squared, I have 169, so this is 169. Next, the next thing is that I will add everything in the square root. So if I add all what I have in the square root, it means I have 144 plus 49 plus 169. Can you see that? 144 plus 49 plus 169. Press the equality sign. Now this is 362. So I have square root of 362. Next, I bring my calculator again and press square root of 162, and this will give me 12.7 approximately. Correct one decimal place. I have 12.7. Square root of 362, sorry, okay, it's 362. Square root of 362, 12.0 sorry, 19.026. Correct one decimal place, it will just be 19.0. So this is equal to 19.0. If you like, you can do this straight away. You can ignore the negative sign here and the bracket and say, okay, square root, I have square root, then you open bracket for all, and then press 12 only, ignore the negative sign, square, plus, oh, this is malfunctioning. Okay, we open bracket and then press 12, square this 12, plus, then 7 square the 7, plus 13 and also square this 13. Now close the bracket, and press equality sign. You see, you get the result directly, 19.0, just as this one. Okay, so we say unit. Okay, we are not given the unit of the vector. We are not told whether it's displacement vector or acceleration vector or force vector, and this is why we are writing this unit, because it's not specified. If we are told that our vector is a displacement vector, then we will write meter here, or we are told that it's a velocity vector, then we will write meter per second, but we are not told. So we write unit here to mean that this is general, it can be any vector. Okay, we just found the magnitude of A. So how can we find the magnitude of B? Now remember this vector B. Okay, I did not write something here. This should be my Roman number 1 for E. So then what about E Roman number 2? E Roman number 2. Vector B, the magnitude of vector B, remember vector B has no component along the x-axis. Okay, this is minus 3 j cap and then plus 7 k cap. So my magnitude of B written as this, or just B without the vector arrow, so this is equal to square root, because I don't have component along x, so I will only take what I have here. So I will open bracket. Remember, if it is negative, always open bracket, minus 3 close bracket squared plus 7 squared. Okay, this is equal to square root of this minus 3 squared. Let's see that. You open your bracket. Can you see? Open bracket here. Minus 3 close bracket, square it, press equality sign, 9 positive. So I have 9 here, plus 7 squared, we did it before and we got 49. So now I will have square root of, I will add this together, 9 plus 49, and this will give me 58. So the next thing is square root of 58. What is it? Square root of 58. Okay, I will get 7.6, correct to one decimal place. This is approximately 7.6 unit. This is the magnitude of B. Then Roman number 3 says we should get the magnitude of A plus B, and A plus B, we calculated A plus B before. Let us bring the result. When we calculated A plus B, okay, look at the result we got. It's a vector. You see, it has component along along x, along y, and along z. So the result was minus 12 I cap plus 4 j cap and then plus 20 k cap. So the magnitude of A will we can write it as this. Magnitude of A plus B, it should be written as this, and this is the only way possible. So this is equal to we have square root. As usual, we take our negative 12, okay, and square it, plus this is positive 4 squared plus then 20 squared, and this is equal to, okay, now we have a square root of, okay, this negative 12 squared, we did it before, and we obtained 144, if you remember that, and 4 squared, this will give you 16, and then for 20 squared, look at it, 20 squared, this will give you 400. So you have 400 here. So the next thing is add everything in the square root. 144, I have 144 plus 16, okay, then plus 400. See that? Everything added. Then now press the equality sign, 560. So this is square root of 560. Now what is the square root of 560 now? You press square root, you see, press square root 560. And what is the result? 23.66 or 23.7 approximately. So we have 23.7 unit. Again, you can do this directly from this step here. You can get the 23.7. How do you do that? Ignore this negative sign, okay, because the square will cancel the negative sign. So you simply press the square root, open bracket, then you press your 12 square and then plus, okay, don't close the bracket until you finish everything. 4 square it, then plus 20 also square it. And now, oh my god, my calculator, I have to buy a new calculator. This one is faulty. 12 squared plus, and then 4 squared plus, and then 20 squared. Then now you close bracket and press equality sign. Oh my god, I made a mistake somewhere. Let me retry. Square root again, open bracket, okay, I open the bracket and then press 12 squared plus 4 squared plus 20 squared. Now you close the bracket and press the equality sign. You see 23.66, approximately 23.7. So you can do that also and you will get the same result. Then Roman number 4 says we should get the magnitude of A minus B. So this one I will make it short. A plus B. From our result we obtain A plus B already, and look at it here. A minus B, sorry, A minus B, this is what we obtain. Minus 12 I cap, this is minus 12 I cap, and then plus 10 J cap, and then plus 6 K cap. Look at the result here. Okay, this is our A minus B. So if we want to get the magnitude of A minus B, written like this, okay, magnitude of A minus B is equal to simply square root of minus 12 squared plus 10 squared plus 6 squared, and this is equal to, so I will use the quickest method. I will just press square root. I will open the bracket. If I open bracket here, I will now press my 12. I will ignore the negative sign. Then I will press the square plus, what number do I have again? 10. I will press my 10 and I press square plus, then I will press my 6. I press the 6 and I press the square, and then I close the bracket now. Then I press the equality sign. This will give me 16.73 or 16.7, correct to one decimal place, 16.7, and this is 16.7 unit. This method is important, especially when the questions are given as objective questions and you are given a very limited time. Maybe you are expected to solve the problem in less than a minute, sometimes less than 30 seconds. You are required to solve the problem because you are given maybe 60 questions to answer in an hour. You see that? If you are given 60 questions to answer in an hour, time management is very important. You have to use the quickest method possible. Okay, but if it is essay structured question, the one you are expected to write, you have to show all you are working. So this method is preferable compared to the quickest one. So we move on to Roman number Roman number 4, Roman number 5, the last one. This is Roman number 5. Okay, it says we should get the magnitude of twice A minus 3 times B, and we got this vector. This is also a vector. We calculated it before. Where is it? Let me bring it here. You see, this is what we got. You see, this twice a minus 3 times b, we got this negative 24. So negative 24 plus the I cap plus 23 j cap, then plus 6 k cap. Now if I want to get the magnitude of this one, I will say magnitude of 2a minus 3b, this is the way you should represent it, is equal to square root. Again, I have minus 24 squared plus I then take this 23 squared plus this one is only 6 here. That is it 6? I'm sorry, this is, let me check again. What we have here is 5 minus 24 plus 23 then plus 5, so this is not 6, this should be 5 and then I square the 5. Next, as usual, I will just use the quickest method since you are familiar with the long one. So I will now press square root, open bracket. I take the 24. Remember we said we are ignoring the negative sign. The square will take care of that. Then plus 23 also, we square it. Okay, 23 squared. Then plus we have 5. So we will press the 5, square it. Now close the bracket. Okay, then you now press the equality sign. 33.6 correct to one decimal place, so this is 33.6 units. With this you have obtained all the magnitude. Now finally they said we should get a unit vector in the direction of a. This is f. How do I obtain a unit vector in the direction of a? How is it written? Okay, unit vector is a cap. Okay, and this a cap is given as vector a divided by magnitude of a. Can you see that? Meaning vector A divided by magnitude of A. This symbol means unit vector in the direction of A. And how do you obtain that? Is equal to, this is Roman number 1, vector A divided by magnitude of A. What is vector A? You know vector A. You also calculated magnitude of A. So where is vector A? Your vector A is negative 12 I cap plus 7 j cap plus 13 k cap. This is vector A that you are given, divided by magnitude of A. What is magnitude of A? Where is magnitude of A? Magnitude of A, you can see, is square root of 367 as 362, which was approximated to 19.0. So I prefer using this one because this one contains approximation. This one is more complete, so I will now take square root of, this is the magnitude, square root of 362, square root of 362. The next thing you should do is to divide each term by this one. This means you have negative 12 divided by square root of 362. This is your I cap, plus 7, this one 7 divided by 362 in square root, and this is your j cap, and finally plus 13, the last one, divided by square root of 362, and this is k cap. This one is the unit vector in the direction of a, and remember unit vector has a magnitude of 1, so try obtaining, as an exercise, try calculating the magnitude of this and it will give you 1. Believe me, it will give you 1. Okay, as in a similar manner you can obtain the unit vector in the direction of b, and this is vector b divided by the magnitude of b. You see, just as this one that we say vector a divided by magnitude of a. So this means here I will have, what is my vector b? Vector b has no component along the x, so I have minus 3 j cap plus 7 k cap divided by, what is the magnitude of vector b? We calculated the magnitude of vector b. What did we obtain? Look at it here. We obtained square root of 58. We approximated it to 7.6. This one is more complete compared to this, so we are taking this one and not this, square root of 58. So we have square root of 58 here, and then as usual we will take this and divide it by this, so we have minus 3 divided by square root of 58, and this is our j cap, then plus since we have plus here, plus 7 divided by square root of 3 square root of 58, and this is our k cap. You see, with this one we have completely solved problem 5 with the extra questions added to help you understand the physics of vectors. I hope these problems help. I believe that you can solve any problem related to this problem 5 and even more. Thank you for watching. In case there is anything you do not understand, let me see the questions on the comment section. Assalamu alaikum wa rahmatullah.